Hey everybody, this is Ben with Devslopes.com. Now that we've taken a good long look at platform-dependent compilation and gotten an idea of the role that it plays in our code, and especially in having seamless transitions from when we've got it in the editor to when we have it on a device, let's get down to business. We've got a big class to fill out and a lot of work to do, so let's charge ahead. Make sure that you are in the Override Orb script, where we've been the last couple of videos. And we're going to get going on creating our functions and seeing some fruits come from our labor. Head down to the follow input function. And the point of this function is to follow the player's movements as far as their touch or mouse input goes and see what they're doing, where they are moving things to, and keeping track of the action. So we're going to start with a vector 3. We're going to call this input pause for input position. And we're going to say get input position. And then we want to say input pause. So input position dot z equals camera dot main dot near clip pane. And then we're going to multiply that by 7.5 f. So we're doing a little bit of math to figure out how far away from the clipping point, the closest clipping point of the camera we are. And we're assigning that to the input position z. Because really, as the player's dragging their finger along, they're pretty much just interacting with a vector 2 rather than a vector 3. But in this case, the z is important, so we need to figure out about what the z is. And then we're going to say vector 3 pause for position equals camera dot main dot screen to world point based on the input position. So we're creating a brand new vector 3 and figuring out where in the world the player is based on where their finger's at on the screen for the X and Y and what we calculated for the Z. And then we're going to use a really special function. Let me type it out and then we'll explain it. Transform dot local position equals vector 3 dot lerp transform dot local position. And then I'm going to send this over here because I want it to be close. Pause. And then 50.0f times time.delta time. Okay. So basically what we're doing here is we're using the lerp function. And what lerp does is smooth the transition from one vector 3 to another. So we've got our starting point and our ending point, and we don't want to just magically jump from point A to point B in an instant. Instead, we want it to smoothly transfer. So lerp handles that for us. And we're using 50.0f times time.delta time to figure out kind of the halfway point and how close or far away from it we are based on time. So point A is our transform.local position. Point B is where we're trying to go. And then we're just smoothing out that transition. Not as scary as it looks at first. Cool. The next function we're going to cover is grab. And this one is super simple. Okay, maybe not super simple, but it's not terrible. We're just going to say ray equals camera.main dot screen point to ray. And then we're going to use our get input position function. And then raycast hit point. So we're sending out a ray so that we can use raycast hit to figure out what the player's touching and make sure it's our orb. The next part is we're going to say if physics.raycast ray outpoint 100.0f and point.transform equals transform. ahead and bring this down so you can see easier. Then holding equals true. And we're going to set the transform.parent equal to null, just to make sure that it's not messing anything up with the parent. So quick fun fact, if you've never seen this out operator before, basically all this is saying that we are passing this variable by reference instead of passing it a copy of the object. So pass by reference instead of pass by value. If you're familiar with C++ at all, it's a lot like using, well, it's exactly like using a pointer. If not, then don't worry about it too much. Just know it's passing by reference instead of by value. That's a good interview question if you're ever in a Unity job interview. Okay, so I don't know why I put those spaces in, because we are done with this function. Cool. Let's move right along. Next, we've got the drag function. And this is going to be one of the easier ones that we've set up so far. We're just going to say last x equals get input position dot x. And then last y equals get input position dot y. And that's it. We're just updating those positions. Easy enough, right? Now for the release, we're just going to say if last y is less than get input position dot y, then we're going to use a function that we haven't written yet called throw. And we're going to pass in get input position. This is just doing a check to make sure that the user's finger or mouse or whatever we're referring to at the moment is at a higher y point than it was. This will prevent the user from throwing the ball backwards or anything like that. Next up, we've got get input position, which returns a vector 2. This, as we've seen from us using it everywhere, looks like a pretty big and important function, right? Well, it is and it isn't. The point of this function is we're going to pass back a vector 2 regardless of the platform that the user's on. So how do you think we should write code that's going to return something back with the same value no matter what platform they're on? If you're thinking to yourself, well, duh, we're going to use platform-dependent compilation, then you're absolutely right. So here's how we're going to do that. This is a great use case to show off what this can do. We're going to declare a vector 2, and we're going to call it result equals new vector 2. Now that vector 2 is just going to be empty. But regardless of what happens here, we're going to be updating it. The way we update it is just going to depend on what platform we're on. So we're going to say if unity underscore editor result equals input dot mouse position. And then we're going to end that directive. And then we're going to say if not unity editor and throw in the end if, just so that's closed and the compiler doesn't yell at me, or rather the IDE doesn't yell at me. Then we're just going to say result equals input dot get touch 0 dot position. And now that that chunk's written, we're just going to return the result. Cool. Now, no matter what platform they're on, whether we're using it in the editor or not, we're going to get a vector 2 result. And that's something we can work with in all of these functions. And we don't have to declare it. We don't have to go through all of the trouble of figuring that out. It technically took 6 lines of code, but that's not quite fair since 4 of those 6 are just directives. Okay, now for the big scary function that we hadn't written yet. We need to write out the throw function. It's going to involve some math, but that's okay. It'll be fun, I promise. So write out private void throw. So we're declaring this new function, And it's going to take a vector 2 that we're going to call target pos for target position. So to start, we want to make sure that the rigid body is now using gravity. So let's say rigid body dot use gravity equals true. Because up to this point, when we go to set up our rigid body on the orb, we're going to turn gravity off because we want it to hover in place, not drop down in front of the player, because then it's useless. And at this point, we want to start tracking our collisions. So we're going to say tracking collisions equals true. Now here comes the math. We're going to say float y diff equals the target position dot y minus the last y. And then we're going to divide that by the screen height. So screen dot height times 100. Now we're going to go and say float speed equals throw speed times y diff. Depending on how you look at things and how you look at math and physics, this is either one of the most fun parts of programming games for you, or it's the worst. So I'm going to try and explain the math as we go to help you understand, if you don't already. Essentially what we're doing here is figuring out the velocity of the throw based on how the throw speed multiplier that we threw in at the very beginning as a serialized field, and how far and fast the user has traveled across the screen over the last little bit. Now, we're going to do something similar for x. So float x equals target pos dot x divided by the screen dot width minus last x divided by the screen's width. So essentially, we're just calculating how much of a percentage of difference there is with the x-axis, where we did the y before. And then we're going to update x and say x equals math f dot abs, so the absolute value of get input position, so wherever the mouse is, dot x, minus last x divided by the screen's width, so screen dot width, times 100 times x. So we're grabbing how much of an absolute difference there was between the last x and where the player is now, and then we're adjusting that for screen width. Next, we need to figure out what direction we are going to be throwing this orb, and we're going to do that with a vector 3. So let's say vector 3 direction equals new vector 3, and we're going to pass in x, 0.0f, and 1.0f. Now that we've figured out a basic direction to start with, we need to transform the local direction, so what's local to the player, and figure out what they're doing in relation to the whole world. So we're going to say direction equals camera.main.transform direction, and we'll just pass in direction and let the main camera's transform functions handle that for us. The next thing we need to do is take the rigid body of this orb, and we're going to add some force to it. So rigid body dot add force, and then we want to pass in the direction times the speed divided by 2f, or 2.0f. And then we're going to add vector 3 dot up times the speed. So that's a lot of math, and I know that's a lot for you to wrap your head around. So if you need to, pause the video, take a minute, and look that code over, and try to get a full understanding of each of those steps that we just did. We figured out where the player was going and the velocity they were going at with the y-axis. Figured out where they were on the x-axis and where they were trying to go. So left or right, pretty much. And what angle left and right. And then we figured out where that direction was in relation to the game's world space instead of just the local space that we were dealing with the orb. And then we took that direction and we added a bunch of force to it and threw it out the way it was supposed to go. The next thing we're going to do is, now that we've thrown the ball, we want to make a sound. So we're going to say audio source dot play one shot throw sound. And then the rest is really easy. We just say released equals true because we've released the ball. Holding equals false. And then we just want to call invoke to give a little bit of time before we call a function. And we're going to invoke power down. And then we're going to add the stall time. So if it doesn't hit anything by the time the stall time expires, then it's going to go ahead and power down or destroy itself. That way we don't have a ball just falling endlessly if the player throws it really, really far. So with that, our Override Orb class is just about done. We have to handle a little bit of collision stuff, but other than that, it's wrapped up. So great job following along. I know this was one of the harder ones to get through, but you did it. Good job. And if you're still a little lost, then again, take a minute, think about it, and review the video once or twice if you need to. It'll come to you, I promise. Again, great job, and congratulations getting through the hardest script that we're going to do in this section. I'm excited to move on and see this in action once we add a collider and a rigid body and do a couple of more minor things. This is Ben with Devslopes.com, and we'll see you next time.